Hi there. Welcome to our presentation for CIVL 302, Engineering, Sustainability, and Economic Analysis. Today we're going to discuss our project which outlines a strategy for how California State University Chico can reduce its carbon footprint, specifically by reducing Scope 3 emissions. Currently, the world faces a unique problem. According to NASA.gov, the industrial activities that our modern civilization depend upon have raised atmospheric carbon dioxide levels from 280 parts per million to 400 parts per million in the last 150 years. It has been concluded that there is a better than 95% probability that human-produced greenhouse gases such as carbon dioxide, methane, and nitrous oxide have caused much of the observed increase in Earth's temperatures over the past 50 years. Because of this, there is a growing pressure from government, business, and society for companies and institutions such as Chico State to find ways to reduce their carbon footprint. In an effort to meet this challenge, our team looked for ways that Chico State could reduce one of its largest emissions contributors, the emissions produced from student commuting. Student commuting accounts for 34.3% of all emissions generated by activities related to the operation of Chico State. Student commuting falls under the criteria for Scope 3 emissions, which are indirect emissions from activities the school doesn't have direct control over, but which are produced strictly due to the school's operations. In order to reduce these emissions, we wanted to look at how increasing online classes at Chico State would affect student commuting and how much kilograms of CO2 equivalents might be reduced. The specific goal of this LCA is to provide school officials with information about how CSU Chico can reduce their Scope 3 emissions by the expansion of remote learning options such as online classes. So the main inventory item that we will be focusing on in this report is gasoline, which is used to power vehicles used by students to commute to and from the Chico State campus. The functional unit is the miles driven by student commuters per year. The life cycle stages being analyzed in this study will be the production and consumer use of gasoline, both of which can be accounted for using the IPCC GWP 100A assessment method in CIVL. Looking at our system boundary, we can see that gasoline is our input, and the use phases under consideration are the production and consumer use phases. The outputs of our system are greenhouse gas emissions such as CO2, carbon monoxide, and nitrogen oxides, all of which can be represented as kilograms of CO2 equivalents. So here's a portion of the Chico State Greenhouse Gas Inventory Report provided to us by Chico State Sustainability Programs Manager Cherie Chastain. And this portion of the report details Scope 3 indirect emissions, from which we found out that an average of 20.65 million miles are driven by students each year. For our study and for the corresponding life cycle inventory, the amount of gasoline being used in student vehicles annually was the only relevant input to consider. To find out how much gasoline contributes to the carbon footprint, we had to know how many miles are being driven by students. The reason we had to use miles driven rather than gallons of gasoline consumed is because CIVL uses miles as the unit of measurement when specifically analyzing carbon footprint for passenger vehicles. CIVL is the life cycle assessment computer software used to calculate carbon footprint in kilograms of CO2 equivalent. So once we got this data, we were able to put the miles driven annually into CIVL, and then it calculated the carbon footprint for us in kilograms of CO2 equivalent. So for our life cycle inventory, the inventory item that we analyzed was gasoline used in student commuting vehicles. The unit to analyze this inventory item was the mile. In order for us to estimate a cost per item, we first had to find the average miles per gallon of passenger vehicles in 2019, which was 25 miles per gallon, according to Wikipedia. Next, we looked up the average cost of gasoline per gallon in Chico, which was $3.61 on December 12, 2019, according to GasPriceWatch.com. Now, with this information, we were able to multiply the average miles per gallon by the average cost of gasoline per gallon to find our cost per item, or in this case, the cost per mile driven. This ended up being about 14 cents per mile. And when we multiply this value by 20.65 million miles traveled by the students per year, we can estimate the total cost of gasoline used by students annually, which is about 20.96 million miles. So for our life cycle assessment, we reference a study conducted by students from Humboldt State, which surveyed 366 students who were then enrolled in online courses. This survey asked these students how the number of miles they drove to school was reduced as a result of taking an online course. We were then able to take the total number of miles reduced divided by the total number of students surveyed to come up with an average number for miles reduced per student as a result of taking an online class. This value is 245.5 miles reduced per semester. Inputting this value into SemiPro yielded a result of 75.5 kilograms of CO2 equivalents reduced per semester as a result of taking an online course. Next, we found out the current number of students taking an online course here at Chico State this semester, which was 3,249. This number reflects a 90% enrollment rate compared to the online course's class capacity of 3,592 available seats. Assuming there were similar enrollment rates as the number of classes offered was increased, we were able to apply the CO2 reduction value to the number of students enrolled in online classes per year. We analyzed three alternatives Chico State might consider. The first was an alternative in which no change was made. The current online class enrollment currently contributes to an emissions reduction of 7.7% of the original 6.4 million kilograms of CO2 equivalent generated by student commuting. The second and third alternatives doubled and tripled the amount of online courses offered, resulting in a reduction of 15.4 and 23.1%. It is important to note that this is a percent reduction of the Scope 3 emissions due to student commuting only, and not a percent reduction of the overall emissions of Chico State. Some of the economic implications of adding more online classes to Chico State is a cost savings for students. Multiplying the miles reduced by the cost per mile of gasoline, which is 14 cents per mile, we discover the cost savings for students for each alternative. The range of savings for students is between $223,000 to $670,000 a year, depending on the alternative chosen. Considering that this proposal is not associated with a significant cost to the university, normal methods of economic analysis are not necessarily relevant. The largest cost to the university for this program could be a system of cameras if they chose to record already occurring courses, or the cost of a professor if they chose to make the online courses completely separate. These costs are most easily assessed by the university itself, as they should have data or records of the cost of courses and be able to make a cost estimate from those. The most considerable economic benefit of this program may be related to the students taking online courses. Ideally, students would save money on fuel and car maintenance by not having to travel to campus for the class. This might not make this program more appealing to the university directly. However, this, among other factors, could make classes accessible for students and increase enrollment, for which would benefit the university. Limitations to our study include reliance on the student-provided survey data from the study conducted by Humboldt State. We cannot guarantee the accuracy of values for miles less given by students, as it is likely up to the student's best guess and not actually tracked over the course of a period of time. In the event that this emissions reduction option was to be further considered by the Chico State, it would be the recommendation of our team to collect more reliable student commuting data using some kind of GPS tracking device, such as the kind that are equipped in smartphones that tell you your estimated commuting times and miles. In conclusion, it is clear that a significant reduction in student commuting emissions can be achieved from the addition of more online classes at Chico State, with our most modest option of doubling the number of classes providing a percent reduction of 15%. Students stand to benefit from a cost savings between $220,000 to $670,000 per year. And finally, this option is likely to cost less to implement than other options due to the fact that Chico State already has systems in place to run online courses. We want to thank you for your time, and we hope that you consider our project to reduce student commuting emissions.